I'm Anil Kumar. Welcome to my series on transformations. In this video, we'll try to understand how to sketch graph for exponential functions. We'll begin with the parent function y equals to 3 to the power of x, and then we'll take a few graphs where the transformations will be involved. So the very first question for you is to sketch the graph of y equals to 3 to the power of x, include appropriate details, and then state the characteristics, right? So we have two parts to this. First, we need to sketch the graph. Second, we have to clearly write down all the characteristics. Now, to sketch the graph, we basically need 5 points. So we need 5 key points to sketch graph. Now, this is common for all the graphs. Whenever you draw a graph, you always need 5 key points. So you have to look for what are these key points, right? So now for an exponential function, what do you think are the key points? Well, one of the most important point is what happens when x is approaching negative infinity. Now these exponential functions have no restrictions on domain. So x is from negative infinity to positive infinity. So when x is approaching negative infinity, then 3 to the power of negative infinity, which is 1 over 3 to the power of infinity, is going to be very small. So this will approach, so in that case we say this y will approach 0, but still it will be positive, right? So this function is always positive. So it approaches 0 from the positive side. What we are trying to say here is that when x approaches negative infinity, the function is very close to 0, but kind of above the x-axis. That's what we are trying to understand. So this is one critical point. Now we could take a point when x is minus 1. So if x equals to, let's write down the values of x on this side, right? So let's say these are the x values, and these are y equals to 3 to the power of x values. So when x is equal to minus 1, in that case the graph will be 3 to the power of minus 1, which is 1 over 3. So that is another critical point. Then we can take x as 0, right? So x could be 0. Anything to the power of 0 is always 1. And if I take x as 1, 3 to the power of 1 will give me 3. I could take 2 also. 3 square is 9. And then we can consider what happens when x approaches positive infinity. In that case, y also approaches positive infinity. So these are your critical points which will help you to sketch fairly accurate graph. Now, let us plot these points on the graph. So at x equals to minus 1, the value is 1/3. So each division is 1 unit here. So that is there, right? Now at 0, anything to the power of 0 is 1. So it crosses the y-axis. The y-intercept is at 1. At 1, the value will be the base of the exponent, which is 3. So 1, 2, 3. And at 2, it rises rapidly and it goes to 9, right? So there are 10 divisions in this graph on each side. So I know 9 is right one lesser than the top, right? Connecting these points, we could get the graph. So we have this graph which will be kind of like this. Do you see that? You have to connect these points and then draw a smooth curve here approaching 0. So that becomes your exponential function y equals to 3 to the power of x, right? So the critical points being this is at 9 when x is at 2, and this is at 3 when x is at 1. At 0, all the points in exponential function will cross the y-axis at 1. So that becomes the graph of the function with all the critical points as mentioned. Now, let's talk about the characteristics of this particular function. Now, if you look at the characteristics, we see that the domain of the function is always all real numbers, right? So let's write down the characteristics now. So let's begin with domain. So domain is x belongs to real numbers, all real numbers. As far as the range is concerned, the y values, they belong to real numbers, but y is always greater than 0, right? So the graph is in quadrant 2 and moves to quadrant 1. It doesn't touch the x-axis, right? Then we have y-intercept at y equals to 1, right? That is the y-intercept for the graph. We see that this graph is always increasing. So whenever you are checking a graph, you have to see from left to right. It is always increasing. Now it is approaching 0 when x approaches infinity. So when x approaches infinity, y approaches 0, of course from the positive side. So that property, we say it has a horizontal asymptote. And the equation of this horizontal asymptote is y equals to 0. Correct? So these are very important properties which you could mention for an exponential function. Is it okay? So these are the properties which we would like to mention. Now there could be many others. For example, it is in quadrant 2 and 1, right? It is non-negative. So like that you could add some more, but these are critical properties which should be mentioned when we are talking about exponential functions. Is that clear? Now let us take up some transformed exponential functions as our examples. So here is our first transformed function. Sketch the graph of y equals to minus 2 to the power of x plus 1. Now we want to sketch graph of y equals to minus 2 to the power of x plus 1. Now here the parent function is 2 to the power of x, right? So parent is 2 to the power of x. So we can begin with 2 to the power of x, apply the transformations to that and get the transformed function. Now here, what do you think is the mapping for transformation? If the parent function is 2 to the power of x, any coordinate point x and y will get transformed to what when we are considering y equals to minus 2 to the power of x plus 1. Now this minus means the reflection on the x-axis, the y value becomes negative. Now, and then 1 means moving the graph 1 unit up. So in this particular case, only transformation or change is happening vertically, no change horizontally. So x value will remain same, however, the y value will get multiplied by negative and then you have to add 1. So we'll get that value by negative y plus 1, correct? So that is how we'll get our transform points. Now, which points to consider? So the key points which we considered last time are the points which you should be considering now also. So in the main function, we will look into the xy points. We'll start with negative infinity. So if x is approaching negative infinity, y approaches 0 from the positive side. Now in this case, after the transformation, we're talking about now minus 2 to the power of x plus 1. The x value remains same. I should have written negative infinity. So when x approaches negative infinity, what happens to y? It gets multiplied by negative. That means, and then it approaches and then plus 1. So when I say negative means instead of approaching from 0 from above, it will approach from below, right? And now we have to add 1. So it is going to approach 1 from below, minus. So our horizontal asymptote has moved from x-axis to 1 unit higher. Do you see that? That becomes your horizontal asymptote. So the graph is now approaching from below. Do you see that part? From below. That is kind of critical to understand, right? Now, the original function 2 to the power of x, if the x value is -1, the y value is half. If x value is 0, y value is 1. And if x value is 1, the y value is 2. Now in this case, the x values, they remain same, which is -1, 0, and 1. However, the y values, we have to make it negative and add 1. So -2 and add 1 means negative half. And then when you add 1, you get plus half. Correct? Negative of 1 and add 1 will give you 0. And -2 plus 1 gives you -1. So those are a transform point on the transform function. So let's plot these points. -1 half. So at -1, the value is half, which is kind of here, right? At 0, 0, which is the origin, and at 1, we get -1. So these are the points which we get. Correct? At x equals to 2, 2 square will be 4, and here at x equals to 2, we'll get -4 plus 1, which is -3. So at 2, we'll get a value which is -3. Correct? You can actually continue and write for 3, 2 cube is 8, and here for 3, we'll get a value -8 plus 1, which is -7. So at 3, you will get 7. 1, 2, 3, 4, 5, 6, 7 with a negative sign. So these points can help you sketch the graph, right? So the graph will be approaching 1 from below as shown here, going through the origin as you can see now, and then cutting across these points and going towards -infinity. Do you see that? So that is how the graph will look like for the given function, right? So this is for y equals to -2 to the power of x plus 1, right? Y equals to 1 is your horizontal asymptote. Now clearly here you can see that the range has changed, right? Now in this case, of course, domain is x belongs to real numbers as we expected, however, but the range has changed. Y belongs to real numbers, but the value of y this time is less than 1. Do you see that? It approaches -infinity. It is less than 1, correct? And it has an x-intercept and a y-intercept. So it has x-intercept at x equals to 0 and y-intercept also at y equals to 0. So it passes through origin. As you can see, right? And end behavior is that when x approaches -infinity, y approaches 1, but from below, and when x approaches +infinity, y approaches -infinity, right? Going downwards. So that is how you are going to describe the characteristics if you are asked for, right? In this case, we just need to sketch. So that graph in green is the right sketch. So I hope that makes sense, right? Now let's take up another example on exponential functions sketching. Here is an example for transformed exponential function. We'll sketch the graph of y equals to 2 to the power of x minus 3 minus 5. So let's compare it with 2 to the power of x. And we are going to transform that to 2 to the power of x minus 3 minus 5. So if you have a coordinate point x and y on 2 to the power of x, how will these coordinates change? So this means horizontal translation 3 units to the right, so x value will increase by 3. Vertically translated 5 units down, so y value will be y minus 5. Clear? So that is what the transformation is. Now, we'll consider 5 points on the graph of 2 to the power of x and see how they change when the transformation is applied. So first point to consider is when x approaches -infinity, y approaches 0 from positive side. But in this case, x we have to move 3 units to the right, but infinity doesn't matter. So when x approaches negative infinity, what happens to y? Y will be approaching, instead of 0, minus 5 from positive side. So it will approach minus 5. So the horizontal asymptote for us will be at y equals to minus 5. So 1, 2, 3, 4, 5. So that is where we are expecting the horizontal asymptote, right? So we'll write y equals to minus 5 for horizontal asymptote. Now let's consider the regular points, which are minus 1, and for 2 it will be 1 over 2. Minus 2, better to take 0. So at 0, anything to the power of 0 is 1. For 1, it is going to be 2. For 2, it is going to be 4. For 3, it is going to be 8, right? 2 cubed is 8. Now, applying the transformation to the x values, we have to add 3 to y values. We have to take away 5. Adding 3 to minus 1 gives you 2. Taking away 5 will make it minus 4.5. This becomes 3, and taking away 5, you have 1 here, minus 4. Plus 3 to 1 gives us 4, and minus 5 from 2 gives us minus 3. 2 plus 3 is 5. 4 minus 5 is minus 1. 3 plus 3 is 6, and 8 minus 5 is 3. So these are the transform points. Let's plot them. So 2 minus 4. So at plus 2, we get minus 4.5, right? So 1, 2, 3, 4.5. That is the point. At 3, it is minus 4. So 3, it is minus 4. At 4, it is minus 3. We're just moving up. At 5, it is minus 1. Right? At 6, it is 3. At 6, it is 3. So these are the points. So we could take some more with negative value of minus, for example. But anyway, we know it is approaching, right? So this value, which is minus 5. So we could extend this graph in this fashion, right? So that becomes the exponential function, which is going to represent the given graph, right? So that is for 2 to the power of x minus 3 minus 5, right? So that is how you could sketch it. I hope it makes sense. Let's take one more example with reciprocal. Now we need to sketch the graph of f of x, which is equal to minus 1 over 3 to the power of x plus 2. Now, when we have 1 over 3, then the graph normally will be decreasing, right? That is going to be the shape of the graph. But when you do reflection, right, so it becomes increasing. Do you see that? So when this is the graph of 1 over 3. But when you do minus, it gets reflected. So this portion comes down, so the graph becomes kind of like this. So that is the graph which we are expecting to draw now. Perfect? Okay. So our base function, which say is 1 over 3x to the power of x, and that is going to get transformed to negative of 1 over 3 to the power of x plus 2, right? So the horizontal asymptote has moved 2 units up, right? Now this is reflection on the y-axis. So the graph is now going to approach from below, right? So graph is going to approach from below. So now in this case, when x is approaching positive infinity, in that case, y is approaching 0, right? So it is kind of important to understand that when x approaches negative infinity, the y is actually also approaching infinity, right? For this function 3 over x. Let's consider this first. And then we'll write for the transform function, right? So when x is approaching negative infinity, y is approaching positive infinity, right? Now if x is equal to, let's say, minus 2, let's say x is minus 2, in that case, 1 over 3 to the power of minus 2 will give you 3 to the power of 2, which is 9. And for minus 1, we'll get 3. For 0, it will be 1. For 1, it will be 1 over 3, correct? So these are the points. And when x approaches infinity, in that case, 1 over 3 will approach 0. Of course, from the positive side. Do you see that? So those are the critical things which we need to consider for drawing the transformed function. Now here, what is the transformation? Any point which is xy here changes to, this negative is for y, right? And this 2 is also for y. So the x value basically remains same. The y value becomes negative of y value plus 2. So that is how the transformation is going to take place. So for the first one, as x approaches negative infinity, the y value will become negative of this, right? So at that time, y approaches negative infinity, right? So negative of infinity is negative infinity. Do you see that part? So this part we're talking about. Is that okay? Now, for minus 2 and 9, the x value will remain the same, which is minus 2. The y value will become negative, and then you have to add 2. So negative 9 plus 2 will give us negative 7. For minus 1, negative 3 plus 2 will give us negative 1. For 0, x value being same, negative 1 plus 2 will give us plus 1. For 1, negative 1 over 3 plus 2 means slightly less than 2, which is 1, 2 over 3 you can say, right? So 1, 2 over 3. And when x approaches infinity, y will approach what? Now, instead of 0, we are now saying negative. So it is approaching from the other side, but 2. So it approaches 2 from the negative side. You get the idea. So that is how the graph is going to be. Now let us see how to sketch it. Now you have seen all these values are less than 2, right? Horizontal asymptote is at 2. So that is the horizontal asymptote for us. Plus 2, right? So this is y equals to plus 2, which you get from here as your horizontal asymptote. Now let's plot the points. Minus 2, minus 7. So minus 2, 1, 2, 3, 4, 5, 6, 7. Minus 1, right there. At 0, it is 1, right? At 1, it is less than 2, right? So these are the good points. So the graph on this side is dropping very fast, exponentially, going towards negative infinity. And on the right side, it is approaching 2. So it is going like this. Do you see that part? So that is how you're going to sketch your graph. So this is the graph for y equals to minus 1 over 3. Minus is outside, plus 2. Perfect. So that is how you're going to sketch this particular graph. So I hope with this, you understand how to sketch transformed exponential functions. So we took 1 over 3 types, that is the reciprocal of an exponential function. We considered horizontal and vertical transformations. That should give you good practice and understanding. Feel free to make suggestions, and if you have doubts, please write them in the comments. Thanks for watching and all the best.